In this episode of the Aging Well podcast, we are joined by award-winning investigative journalist Charles Piller to discuss his forthcoming expose, Doctored: Fraud, Arrogance, and Tragedy in the Quest to Cure Alzheimer's. This groundbreaking work reveals how scientific misconduct and systematic greed have derailed Alzheimer's research, wasting billions of dollars and decades of potential progress. Charles brings us into the world of whistleblowers, fraudulent research, and the critical fight to reclaim integrity in science. Together, we'll explore the profound implications for his findings, not only for Alzheimer's patients and their families, but for the future of scientific research as a whole. If you care about public health, science, and truth, this is a conversation you won't want to miss. Charles, welcome to the Aging Well podcast. Can you start by just telling us a little bit about yourself and how you came to be a journalist blowing the whistle on scientific research?
Well, first of all, thanks so much for having me. I appreciate being here. Sure. I have been working as a journalist on scientific and technical subjects for many years. I've reported on a lot of things in my career, but maybe for the last 15 plus years, I've been strongly focused on science. A lot of stuff related to biological sciences, which is a long story in my career. I, many years ago, was doing a lot of work on biological warfare issues and wrote a book on that. And in recent years, I've been working for that specialize in medicine and biological sciences. In particular, I work for STAT, which is a website that covers medicine quite extensively. And the last few years, I've been at Science Magazine, where we have a focus in particular on research. And my area has been looking at biological research and also clinical research. So that's experiments involving people to test the safety and efficacy of drugs.
So what inspired you to delve into the world of investigative journalism, and particularly in the realm of public health and science?
Well, at the risk of dating myself, I'm old enough to have been inspired by the reportage of the Watergate reporters back in the 70s. And I was a kid, but I read that stuff, I heard about it, and it kind of prompted me to want to try to use journalism in a way that could benefit society by exposing wrongdoing or problems just that require some attention. Because I've always had a bit of a technical bent, you could say my personality, I'm interested in technical subjects. I've always been curious to try to figure out how do you describe a complex set of information about science or technology to a general audience, to people who are curious but don't have the time to become an expert themselves. And so I view myself as someone who both uncovers information about potential challenges, problems, issues in the world of science, but also who can communicate it in a clear, coherent, and I hope pretty easy to understand way to people who are my readers.
That's going to be especially challenging in this age of TikTok, Instagram, and YouTube Shorts.
True enough. I have to tip my hat to some of the folks who are truly experts in bringing a complex science to the masses, but I'm more of a word guy, but I do the best I can.
I like the words too. So can you share how your reporting for Science has led you to uncover this web of misconduct in Alzheimer's research?
Yeah, I'd be happy to do that. So started in 2021, and I was tipped by kind of an indirect route via a colleague of mine to a source who understood well and was involved in exposing apparent misconduct associated with an Alzheimer's drug. The name of the drug is Simufilm, and it was produced by a company called Cassava Sciences. And a complaint was made to the Food and Drug Administration, which is the agency, as people probably know, that administers and regulates the approval and warnings associated with prescription drugs and some other drugs as well. And after a series of conversations with this particular guy who had been looking into problems associated with science behind the drug, and when I say problems, I mean apparent misconduct associated with manipulation of images in the scientific papers that supported the development of the drug. So in other words, what you might call in simple terms, possible fraud in the development of the drug. In my communications with him, I learned from him that there were some bigger questions in the field, bigger questions initially associated with a set of important research, in particular, a very famous and very highly cited study in the journal Nature, which is one of the most important scientific journals in the world. And this study involved a kind of a proof of concept for the most important, most dominant hypothesis in the field of Alzheimer's research. It's called the amyloid hypothesis. And I can explain, if I may, very briefly what that is.
Absolutely. Please do.
So the thinking behind this so-called amyloid hypothesis is that a certain type of proteins called amyloid beta proteins accumulate in the brain, and they can take a couple different forms. One is the kind of infamous sticky plaques. These are deposits of amyloid proteins in the brain, and also a form that can dissolve in cerebrospinal fluid, which is what the brain is bathed in. And that's a different kind of amyloid beta protein, but both of these are regarded as something that set into place a series of biochemical changes in the brain that lead ultimately to Alzheimer's dementia. And so this idea, which is a pretty interesting idea that had a fair amount of scientific basis and support, became very well accepted as not just a hypothesis, but for decades, for the last several decades, the dominant way of looking at the disease. So just to take, again, I'm sorry, one step back to this scientific study in Nature. This was published in 1996, so it was a long time ago. I'm sorry, forgive me. I'm a decade off. It was published in 2006. Still a long time ago, but not quite as far back. This involved an experiment with mice and rats. And basically what it did is it used mice that had been genetically engineered to produce copious amounts of this amyloid beta protein in their brains. And the idea is to create mice that, in a way, mimicked the symptoms of Alzheimer's disease as an experimental model. Very typical kind of approach in biological sciences. And so what the scientists did, and these were scientists at the University of Minnesota, they extracted something they called amyloid beta star 56, a very precise type of amyloid beta protein, very precise with its own certain characteristics. And then they described an experiment where they purified this protein and then injected it into rats. And what they claimed was the rats then very quickly showed memory problems that they compared to some of the decline in memory among Alzheimer's patients. So what you had was a kind of example, the first example, if you will, experimentally, of a cause and effect relationship between amyloid beta proteins and Alzheimer's disease, albeit in rodents, not in people. And so what Whistleblower, who I was talking with, was learning, and his name is Matthew Schrag. He's a neuroscientist at Vanderbilt University who has become an important researcher in research integrity in the field. And I might add that Matthew, who I've been working with now for several years he does his image integrity and research integrity work separate from his day job as a professor at Vanderbilt. So what he was learning was this particular study in 2006, this famous study in Nature that had been extremely influential and had kicked off hundreds of millions, perhaps even billions of dollars in funding to further investigate and prove out the amyloid hypothesis associated with this certain type of amyloid protein. And it really steered a lot of thinking in the field to validate this hypothesis at a moment when it was beginning to find a lot of skepticism against it. And because it had been trying for a long time to develop drugs or vaccines to treat Alzheimer's without success. So what he found was that several of the key images within this scientific study had been altered, apparently digitally altered in ways that described the experiment as successful. And yet, when you alter images improperly to support your experimental hypothesis, it really pretty much says that you don't have the support that you need. This was, in fact, if this was done, it would be a form of extreme scientific misconduct. So this was the genesis of my interest in this. And so what ultimately resulted was a story that I did in Science. And Science, as your listeners may know, is also one of the leading scholarly journals in the world. Of course, we also have a journalism side of the magazine, and that's the part I work for. I'm not a scientist. Don't play one on TV. I am simply a journalist working on investigative stories about these kinds of matters. And then they're published in Science magazine and now in my book, Doctored. So just to cut the story short, to the chase, I should say, the story is published in Science in July of 2022. And it caused kind of a gigantic explosion of both in the scientific community, because it cast doubt on a prevailing hypothesis in this important disease, but also it had ramifications beyond into the world of the families, the people who are living with Alzheimer's, doctors who are treating Alzheimer's patients. It basically raised a lot of concern about whether there had been incorrect thinking in the field for many years that had wasted time, wasted scientific thinking, and billions of dollars in investment. So that got me off on a much bigger look at the whole panoply of studies and ideas within Alzheimer's. And I had to ask myself the question, if this important study had apparently been doctored, then what more might there be in the field to look at? What other possible examples might there be of apparent misconduct that could have had deleterious effects on the way people think about the disease and how drugs are developed? And that got me off on a long chase that resulted ultimately in my book. And there's lots of other examples that I was able to uncover and describe in the book, as well as in the pages of Science magazine.
So the subtitle of your book refers to fraud, arrogance, and tragedy. How do these elements intertwine in the story you uncovered?
Well, thanks for that question, Jeff. I think the intertwining aspect is very important. So what you have are a few factors. One is you have the dominance of a single set of ideas called the amyloid hypothesis within the field. Doesn't mean that it's exclusive of every other way of thinking about Alzheimer's. Obviously, the world is big, diverse, and complicated. No single idea can completely dominate. But when you have an idea that has got such support in the scientific community and among funders, regulators, universities, and the scientific hierarchy, if you will, including journals, it exerts an enormous amount of force and pushes people in the direction of studying it to the exclusion of other perhaps promising ideas. So when I say arrogance, what I partly mean is this kind of sense of certainty that we have the one true idea about this disease to the exclusion of other ideas. So I think that arrogance played a role in the problem we have, which is that there have been no good drugs developed for Alzheimer's, really ever. There are some drugs in the market, and I can very closely describe those when we get further into the conversation. But just to go back to your question about these three issues, fraud, arrogance, and tragedy. Well, the fraud is that, as I describe in Doctored, there are hundreds, perhaps thousands of examples of doctored studies just in the work that I did with the collaboration of some expert, what we call image sleuths, people who are forensic image analysts who can look at scientific images and understand whether they have been improperly altered. Just for Doctored, we looked at thousands and thousands of images that seem to have been improperly altered in important studies related to Alzheimer's disease. So even though it's still, a small percentage of the overall body of work for the field, you have to ask yourself the question, if we were able to find all of these apparently doctored images that had the effect of suggesting truth within scientific experiments improperly, it really raises some bigger questions about how reliable the body of research is overall in the field. So, and there's a couple of examples I can talk about later that really bring that home. But just to get to the third pole of your question, tragedy, what is the tragedy? Well, as millions of Americans who are living with Alzheimer's and many millions of their loved ones who are caring for them know, this is one of the most horrible diseases that we've ever encountered. It steals people's, first their memories, then their ability to have normal relationships with their loved ones, and eventually a kind of theft of their sense of self that makes each one of us human. And because of that tragic sequence within the illness, it's a terrifying one. And the scientific community, the medical community, owes this patient population and owes all of us a kind of determination to think broadly about these issues and about what the possible solutions would be. So if I could just use briefly a kind of agricultural analogy that I think people might want to think about in regard to this problem of why is it a problem to focus so closely on a single hypothesis? Well, if you think about farmers and how they grow crops, they don't grow the same crop on the same field year after year after year after year for fear of depleting the nutrition in the soil. And in a sense, what an over-concentration of work on one hypothesis in this scientific field, the amyloid hypothesis, it can create a kind of scientific monoculture, if you will, that depletes the surrounding area of intellectual creativity for other kinds of ideas. So I would say those three things: the fraud that describes the part of the book that details dozens and dozens of scientists whose work is now, I think, challenged and questionable. The tragedy, of course, is the patients and their loved ones who are waiting, hoping for a remedy that has real effectiveness. And the arrogance is the idea that people feel that they're so right that they kind of crowd out other creative thinking.
Yeah, and I would imagine that your work has really just exposed the tip of an iceberg. And there's probably a lot more deeper stuff going on throughout science and throughout, pharmacological development and all that kind of stuff. Can you describe the role of whistleblowers like Matthew Schrag, was it? Right?
Yes, Schrag.
Matthew Schrag, and their role in kind of exposing fraudulent practices in Alzheimer's research and really other areas of science?
Yeah, I'd be happy to. Before I describe my work with whistleblowers and what their contribution has been, I'd like to say, first of all, that I think it would be a mistake to assume that because some research has been apparently product of misconduct or even fraud, that you can paint a much broader brush with it. We don't know for sure. We know that while there is fraud and misconduct in Alzheimer's research, I certainly don't think it's more than in other fields of research, nor do I think it's more than in any other walk of life. We know that almost every field has people who are corrupt or who are willing to cut corners, who are willing to rationalize themselves that somehow their thinking is so important that it's okay for them to do things that other people would regard as improper. But I still think that most scientists in the field are deeply determined to do the right thing and to be genuine researchers of important scientific ideas, even if they might, disagree with each other or even make mistakes. We all make mistakes. So I would be hesitant to paint too broad a brush with this. The second thing I wanted to say is that even though my book describes an enormous amount of failure by the institutional authorities of science, and when I say institutional authorities, I mean the federal regulators, the funders, the journals, and the universities that have been very complacent and have not properly address the issue of both image integrity and scientific integrity more generally among the people in their ranks. So while I'm very critical of their inactivity, their lassitude, their complacency, I still want to say that we have a robust and I think very effective, compared to the rest of the world, most of the rest of the world, very effective way of evaluating possible drugs for human use. We have a very robust and I think very effective infrastructure for studying medical and scientific questions that have reaped an enormous reward. So I just want to be clear that I am not a critic of the entire scientific establishment. I believe I've focused clearly on some lapses, some blind spots, and some corruption that needs to be exposed. So I'm sorry for that long digression, Jeff.
No, that's quite all right. And I agree with you. But I do think that, it's good to have that skepticism, because I think too often we have too much trust in the scientific community and, the companies that are developing drugs and the FDA and all this kind of stuff. And it's important that we have people like you that are testing that integrity and challenging it and making sure that we're getting the information, I think, that is honest and legitimate, and that it's not tarnishing the reputations of good scientists that are out there.
Thank you for saying that. I do agree. And I think just to tie back to your question about whistleblowers, so why are there whistleblowers? And why are there people who I have called image sleuths? That's what they often call themselves. As I mentioned, the gatekeepers and the authorities of science have not done a good job of policing possible misconduct and image manipulation. And so what has happened, and this is so often the case today, given the rise of social media, the internet, and the kind of new constellation of thinking that has often been stimulated by that, what we've seen is that image sleuths have formed a kind of a cottage industry of policing the field, because it's not being well policed by the authorities that should be doing the work. And let me just give you an example. The scholarly journals have been very late to the game in understanding how important it is to check the images that are submitted to them for possible fraud. And reviewers, which are the people who review these studies before they're included in scholarly journals, they look at the studies, they provide feedback. These are subject matter experts within the particular field. These are folks who we depend on for their intellectual integrity and for their knowledge to make sure that the work that finds its way into the scientific record is good, it's well-founded, and it's been well-checked. But they're not trained to look at images with a critical eye. They're not trained to see, there may have been improper alterations in these images meant to support the experimental hypothesis in an improper way. And so what has happened is that these image sleuths, a kind of a army of them, a small army from all over the world, have developed the skill to do that image analysis. And a lot of the information that they find is posted to a website called PubPeer, P-U-B-P-R, if anyone wants to look it up. And this is a website that is a kind of a discussion site for scientific studies. And the suspect images are posted up there often with questions for the researchers, saying things like, these images don't look right to me in this way or in that way. Can the authors of the study please check and respond? And usually they're presented in a way as a question, because it can be very hard to know with certainty whether an image has been improperly altered without having the original high-resolution images that were produced for the experiment. Unfortunately, so often, the experimenters won't supply those original images. And so, in my opinion, that's a pretty bad look. They need to be more forthcoming. So what you've seen is an explosion of interest from these image sleuths, many of them anonymously posting to this site, PubPeer, that has caused a real crisis of confidence within many of the scholarly journals and in the scientific community. And not every criticism made of a paper is correct. Sometimes these image sleuths are simply wrong in their understanding of their analysis. But it's up to the journals and the scientists who studied those to set the record straight if they can. But unfortunately, in a very large percentage of cases, they have genuinely found improper activity on the part of these scientists. But if I could just digress for a second, Jeff, and respond briefly to your question about whistleblowers. So whistleblowers are people who come forward with original information about these studies, often from inside the scientific environment where they were produced, but not always. And they often take extreme personal risks to do so. They could be risking their careers. They could be risking their jobs. They could be risking the possibility of legal action against them from people that they would be criticizing. And so often they're doing things in I think, a quite heroic way. For me, as a journalist, I encounter whistleblowers all the time. They come to me with problems and concerns. But I have to say that it's only a minority of them that are willing to be even named publicly in an article because of the risks that they run in doing so. This guy, Matthew Schrag at Vanderbilt, was one of those rare breed of whistleblowers who, as a junior professor at Vanderbilt, kind of staked his career by being willing to anger the institutional authorities in his field. He's an Alzheimer's scientist, and he was challenging journals and top scientists in the field and the National Institutes of Health, who funds his own work, and others who have some real say-so about whether he can advance in the field. And yet he felt that it was so important to set the record straight and to get the field away from ideas that may have been based on improper information, that he was willing to be named in my story and in my book as an important element of how I tell the story about false research in Alzheimer's. And if you'll forgive me, one small description about the book itself. Doctored is an investigative narrative. And I want readers to understand that even though there is, of course, technical information in it and descriptions of technical information, it's written for a general audience. It's written for people who want to follow the story of how these problems emerged from the perspective of the players in the story, the people who were implicated in possible wrongdoing, the people who uncovered it, and how the drama unfolded. So I would just encourage people not at all to be intimidated by the science of it.
Yeah, it sounds like a fascinating story, and I've got to get the book and read it, and I will. I'm excited for it to come out. So how have these fraudulent studies misled Alzheimer's research and the funding over the last 2 decades?
Well, as I mentioned, the genesis of the book had to do with this so-called amyloid beta star 56 study. And this was the study in this journal, Nature, in 2006, that really set the field a bit on a path of reinvigorating the amyloid hypothesis that had been the subject of some skepticism by then, because already by then, for more than a decade, a lot of tries have been done at producing drugs that would Alzheimer's in an effective way, and they'd failed. One after the other had failed. And it injected, just as the drug was injected into rats to cause these memory problems, the study itself injected into the field new hope and new determination and new belief that this special kind of amyloid beta protein, I'm going to use this technical term, oligomer. It's a word that refers to this kind of amyloid beta protein that can dissolve in cerebrospinal fluid, and it refers to its molecular weight. So it's kind of a heavyweight type of amyloid beta protein. The idea shifted to thinking that was one of the key elements to knocking out the Alzheimer's symptoms or slowing their progression. And so what happened is that hundreds of millions of dollars from the National Institute of Health almost right away, ultimately amounting to billions of dollars, went into the studies associated with amyloid beta oligomer proteins like star 56. And additionally, pharma companies put in billions of dollars into fighting the disease based on that same hypothesis, that same intellectual target, the style of amyloid beta proteins, as well as the sticky plaque form that accumulates in the brain. And so say that, first of all, a study that has been shown to have been based on image manipulation, and I might add was in 2024 finally retracted as a result of that, study had profound influence in the field. Now, it wasn't the only study, obviously, the only study in that field. There were many studies, some of which gave people optimism. But this was the study that, in a way, triggered this burst of activity to suggest that this was the one true path to solving this problem. So if I could play it out a little bit further, just on this one element of it, the way this is played out is that in the last couple of years, there have been finally a couple of drugs approved by the Food and Drug Administration. 3 actually have been approved that attack amyloid beta proteins. And these were very significant approvals because they are what the field calls disease-modifying drugs. So there's drugs on the market now that can treat symptoms of Alzheimer's. For example, insomnia or agitation, which are sometimes symptoms of the disease, can be treated with certain drugs with some effectiveness. But when I say disease-modifying, I mean a drug that either stops, slows, or reverses the symptoms of Alzheimer's. That's the kind of the ultimate goal of all this important drug development. And so these 3 drugs were approved. One has been withdrawn from the market because it was dangerous and ineffective. The 2 that are still on the market, one is called Leqembi, and the other is called Kisunla. And Leqembi was the first of those 2 that was approved by the Food and Drug Administration. And so both of them are based on removing amyloid beta proteins from the brain, and they both do an excellent job of removing particularly the sticky plaque form of amyloid beta from the brain. And so why were these approved? Well, they were approved because in clinical studies with patients, Alzheimer's patients, they found that to a statistically significant degree, the pace of cognitive decline in patients was slowed. So when I say that, let me just be clear what I mean. It meant that all of the patients in the study, those being given the drug, the experimental drug, and those being given the placebo, which is a dummy treatment that mimics the experimental treatment but really has no intended benefit, they found that those being given the drug still declined. Their cognitive ability still declined steadily, but at a slightly slower pace than the people taking the placebo. This was shown to a statistically significant degree based on the testing, the somewhat subjective testing that is done of people's cognitive abilities. So why would I not be then enthusiastic about this? Even though it's not a cure, it's something that could potentially benefit patients. Well, there's a couple things to keep in mind. One is that it had a statistically significant benefit, but many doctors, in viewing the results of this drug, do not regard it as what they call a clinically significant benefit. In other words, the difference in the pace of cognitive decline was so slight, such a small difference, that it was imperceptible in many cases to patients, their families, or doctors. So many doctors won't prescribe the drug at all because, one, the benefit is very low. And you might ask yourself, well, why not try it, even if the benefit is uncertain or might be very subtle? The reason is that it also has really serious hazards associated with it, even including the risk of death from brain swelling and bleeding or the risk of brain damage. And so doctors who are prescribing this drug have to ask themselves, how do I advise my patients to think about this? Many patients are so terrified of this disease that they might be willing to roll the dice, and naturally that's their prerogative. But I think many doctors are faced with the dilemma, is this good advice to have them take a drug that they may not even see any personal benefit from that could actually kill them? And I know a lot about this in part because I wrote some of the original stories about deaths within the trial for the first of these drugs, Chemby, back a couple of years ago, where people in the trial were dying of brain swelling and bleeding in sometimes horrific manner. And these, in the reporting and the scientific studies that followed about them, to the FDA putting their most stringent warning on the product label for these drugs. And that's what they call a black box warning, denoting a risk of death. So let's be clear. These drugs are on the market. They're very expensive. Even if Medicare pays for them, the copays are pretty high, many thousands per year. But if you're not having insurance pay for it, including the brain scans for safety and diagnostic reasons that you must have with these drugs, it can amount to many tens of thousands of dollars per year per patient. I guess what I'm saying is that this is an example of how the degree of success we've had has been very modest, even though billions and billions of dollars have been invested in this amyloid hypothesis and the products that could result from them.
Yeah, it gets a little bit scary how once billions of dollars have been invested into a drug, how often it's very hard to kind of retract the progress or to put the brakes on the progress because you feel like this has been spent, we got to do something with it. So what role do agencies like the FDA and some of the big pharmaceutical companies play in perpetuating these issues that you're talking about?
Yeah, thanks for that question, Jeff. It's really at the heart of the matter. So what we have here is a matter of sunk costs. So when a company has invested billions of dollars into a line of research or into drug development, really need to see a return on their investment, even if the result is lackluster or worse. But there's another side to it, which is that, well, two other sides, really. One is that because the field has been so dominated by the amyloid hypothesis, there are hundreds of thousands, perhaps, of scientists who have spent their entire careers studying this idea and how to use it for public benefit in solving the problem of Alzheimer's disease, so far without all that much success. And as a result, their entire careers are based on this idea that they have to continue to support, or, they risk feeling like their life's work has been leading them down a blind alley. So there's enormous, any human being might feel this enormous psychological pressure to continue to prove out every little permutation of this idea in a way that could ultimately result in its success, even in the face of a lot of failure and also crowding out other possible ideas for curing the disease. With regard to the institutions, I just want to say that FDA, again, an institution that has done a stellar job in many ways. I am not an FDA hater. I like FDA's work in many realms, and I feel that they've done an excellent job in protecting the American public and the drug supply from unsafe medicines or from ineffective medicines, even though they make mistakes and even though they sometimes make, in my view, the wrong move. But in this case, there is enormous pressure, understandably enormous pressure from patients and from patient advocates who, by the way, are often heavily funded by the drug companies developing these drugs, for the FDA to act, for them not to slow down the approval of drugs because they might be either too dangerous or so minimally effective for the cost as to make them kind of questionable. And so the agents feel enormous pressure from the drug companies that are lobbying them, from patient advocacy groups that are lobbying them, from Congress who are saying, we're spending all this money on grants. We need to see some return on our investment. That the temptation to let through drugs or let testing continue on drugs despite apparent problems in the testing process is just enormous on the agency. And unfortunately, they sometimes, in my opinion, don't always make the right move as a result of that.
So how does the lack of consequences for the perpetrators affect the scientific community and the public trust in science?
Well, this is really the great tragedy of it, which is to say that scientists and doctors have been, I think, really unfairly been under attack by many people who have political motives for doing so. I do not subscribe to those attacks. I am, for example, a believer that scientific research in areas like vaccines have been some of the most important in human history for safeguarding all of us from terrible illnesses. That said, there's a lot of hubris in science. There's a lot of attitude of like, trust us, we're the experts. And let's face it, trust has to be earned. And scientists, like anyone, make mistakes. They have problems. There are people in the ranks who are dishonest. And the scientific institutions, the journals, the universities, the federal government, the regulators, they have not effectively policed the field. And so as a result, they've ceded some of their moral authority to be able to respond to concerns that are raised about the field and to try to engender trust in the process among members of the public. So what I think the good news is that it's slowly changing. Those institutions are slowly kind of getting a feeling that they're in some trouble in that way. So I'm going to tell you one reason why I'm somewhat discouraged and one reason why I'm somewhat hopeful. So I want to mention, this is a story I did about a guy by the name of Eliezer Mosley, who was previously of the neuroscience division of the National Institute on Aging. So that is a job that is responsible for funding more Alzheimer's research than any other entity in the world. So they give more grants in that realm than anybody else, billions of dollars per year. And so this is a very important guy because his thinking and his reasoning and his leadership and judgment had been for years at the pinnacle of the grant-making institutions that we rely on for the furtherance of thoughtful, incisive research that could ultimately lead to treatments and cures for the disease. And my reporting, in conjunction with Matthew Schrag and three other illustrious image sleuths, if you want to call them that, Elizabeth Bick, Kevin Patrick, and Mu Yang, a dossier was developed on his work associated with his vast contributions to neuroscience. This is a guy who had written like 800 scientific papers. Not all of them, but a fairly large chunk of those were looked at by that team, led by the pioneering work of Mu Yang at Columbia University. And these sleuths found that 132 of his papers had been apparently based on image doctoring. It's shocking, really, because this guy at the pinnacle of funding of the field was himself implicated in a just, really elaborate set of problems. And when my story came out, the day it came out, he had to be forced out of his job. So the epilogue, in a sense, of this little anecdote is that I went to the National Institutes of Health, which is the overall agency that sits above the National Institute on Aging, which was the agency that Mosley was part of. And I asked them, when he was hired or when other senior people at your agency are hired, do you just do a routine check for possible image doctoring or other kinds of potential scientific misconduct before hiring people for these high posts? The answer was, no, we didn't. No, we don't. And we don't think it would be helpful. And to me, this was a shocking kind of arrogant complacency in the light of this scandal that they had just faced with one of their top leaders. So to me, that is the discouraging side of the story, that we still have a kind of a sense of entitlement almost from some of the agencies that they just haven't taken matters into hand in an appropriate way. The plus side is that I think journals and to some degree universities are taking these issues more seriously. Journals are starting to adopt software that can look at images quickly and give them a hint as to where there might be problems that they need to address in a more determined way. And so that's one good sign. The other good sign is that people are looking over their shoulders. The rise of image sleuths in my view, has been a positive sign in the scientific community that it's just important to crowdsource some of these things. The problems are too large. The issues are too large. Now, that is not to say that every finding by these people is correct. And it's not to say that they sometimes don't engage in excesses like personal attacks on scientists that I would think are not at all warranted and often are counterproductive. But I would say the vast majority of people who are part of this community of image sleuths are respectful and deeply determined merely to expose fraud or misconduct in research in a way that could correct the scientific record. And to the degree that we can begin to correct the record, we can really unwind from some of its terrible effects and move the field forward much faster. By exposing incorrect information, the field can, in a sense, cleanse itself and move forward more rapidly. And that's really what it's all about, to help serve the people who are living with Alzheimer's, their families, and our own future much, much better.
So from your experience, what motivates these sleuths and these image individuals that you're talking about? What motivates them to do what they do, and how are they really making a difference?
Well, I think, it's a diverse group like any group of people. But I would say that, the image sleuths are people who, question authority, are not afraid or intimidated by authority, who are also themselves technically interested. A lot of them are not scientists. They're just people who know how to use software and know how to look critically at images and try to understand how they were constructed or how they were tampered with. And, I would say they're mostly hobbyists, just people who have fun doing this and want to make a contribution. And in a general way, like any group of people, like scientists, the vast majority of them have good intentions, are thoughtful, and would like to see an improvement of the field. There's some who don't. There's some who are cavalier or unfair and perhaps antagonistic to some of the targets of their examinations. But look, that's the way it is with humanity. We're a diverse group.
Okay, so my next question, I don't want to bring politics into it or any of that kind of stuff, but I think we are kind of looking at a potential pendulum swing here in the next administration. But with that being said, what role can policymakers, healthcare professionals play in ensuring a greater accountability and transparency?
Yeah, that's a terrific question that I've been, fretting about myself. And the reason I've been fretting is that I think there is both potential and danger in the coming period. And so we have to face facts. A lot of these institutions, including the National Institutes of Health and the FDA, have not done as good a job as they must do to root out misconduct or fraud in studies that they examine, fund, and approve for drug development. And so step one is to fund and encourage and equip the agencies to do a much better job of that and to insist upon it. And that is something, forceful new administrators at those agencies can and should do. I think there's been complacency and a sense of arrogance that has to be corrected. So that's something that I would welcome. What I would not welcome is an attitude of or restricting the scientific judgment of many of the experts in these agencies who have done, in my view, in most cases, an excellent job of scouting out ideas, of providing rigorous review to important drugs. These are not institutions you want to mess with so much that they can't do their jobs effectively. Look, I have written about the FDA and the NIH critically many times. I have done numerous investigations about their failings and the failings of the CDC. But I do it from a perspective of the work that they do that we all benefit from and insisting that they do better. It's our obligation to do that. And look, if people who are supportive of these agencies don't criticize them from a perspective of support, you might say, don't expose problems that they might not even be aware of themselves from a perspective of, we want these institutions to do their jobs better, then people who basically want to use them or misuse them for political purposes or destroy important programs to meet the needs of some perceived or actual constituency that they think they have, then those people will have free rein. We have to find an approach that strengthens the institutions and makes them do better, not hacks away at them in a way that will create really desperate needs for better intervention.
So shifting gears a bit, and we ask this of all our guests, what are you doing personally to age well?
Okay. Well, I've got two things that I think are keeping me younger than I would otherwise be. One is that I am fascinated by the work that I do, and I feel very privileged to have a platform where I can think deeply, spend an enormous amount of time learning about new things in science, and stretching my brain to try to interpret it for the public. That is a great gift that I've been given through my hard work, of course, but also I know that so many others in society would like to be making those kinds of contributions. And even though they're well qualified, they haven't been able to. So I'm very happy and I feel very privileged about that. The other thing is that keeps me going in that way and keeps me young is spending an enormous amount of time with my 2-year-old granddaughter, who is one of the loves of my life. And she's amazing. And she also forces me to stay in the moment. That's what 2-year-olds do. And it's a great gift to me as well.
Hey, it's an important part of aging well is kind of living in the moment.
Indeed, it is.
Not living in the past, not living too far in the future. So is someone who is so deeply immersed in this investigation, what gives you hope for the future of Alzheimer's research and patient care?
Well, a few things. One is that I think, notwithstanding the dominance of the amyloid hypothesis, which is something that I'm not suggesting should be completely abandoned. Obviously, it's obvious that amyloid proteins have something to do with Alzheimer's, but I'm encouraged that there's the start of much more diversified research going on. Some interest in things like what's called the infection hypothesis, that Alzheimer's might be related to brain infections. Also, the inflammation hypothesis that different causes of inflammation might be contributing to the development of Alzheimer's dementia, and others. And in fact, there's some pretty fascinating studies that are coming out soon. One related to the GLP-1 inhibitor drugs. These are the weight loss drugs that have been yielding what some people are calling kind of seemingly miraculous benefits. These are now being tested as possible remedies for dementia. And so I guess what I'm saying is that never underestimate the power of creative thinking of the scientific community. That is going to help us in the future. The second is never underestimate the determination of image sleuths to root out potentially bad behavior and to make sure that attention is called to it and slowly but surely force the scientific community to do some self-policing that is more effective. Those are two things that give me a lot of hope for the future, even though a cure for Alzheimer's, I think, is still a ways off. I think we should all at least hold out some hope for ourselves that this isn't an endless problem.
That's good. And are there any upcoming projects or areas of investigation you're excited to share?
Well, unfortunately, I can't share what I'm working on now. It's just sort of the thing about I can't pre-disclose stuff that's going to happen in the future in my field.
So it just means we got to watch your work and watch for all the great projects coming out, right?
I'd be very grateful if you did. You can find me on my webpage on Science Magazine. And also, of course, my book's coming out. When you listen to this, it'll be out. And I'll be, very eager to hear any feedback that readers might have.
And we'll have links to that and to your website. And you do any social media or anything else like that?
I do. I'm on Twitter and starting to get going on Blue Sky.
All right. Well, is there anything we missed today? I feel like we talked about so much, but I want to make sure you have your voice fully spoken today.
No, I really appreciate the opportunity, Jeff. I think your questions were the right ones to get to the heart of the matter, and I'm very appreciative to have the time taken to get a look at the work that I'm doing.
All right. Well, when you have some of that more I was going to say more important work, but it's not really more important work. The additional important work that you have coming out in the future, as that comes out, keep us in mind, and, we'd love to have you share it here with us, because, we want people to get the right information to be able to age well. And I think you're providing that information, so we thank you for that.
Okay. Thank you again for your interest.
Thank you for listening. I hope you benefited from today's podcast. And until next time, keep aging well.